negative 2 and negative 3. Here's negative 2 and negative 2, and the point negative 2 and negative 3. We draw a line between them. We have x1 and y1 coordinates, which is form an ordered pair of negative 2 and negative 2. And x2 and y2 has an ordered pair of negative 2 and 3. We use the definition of the slope as the change in y over the change of x, or the rise over the run. So we used y2 minus y1 where we defined it earlier. Therefore, that's 3 minus 2. And then the denominator, it's x2 minus x1. So a negative 2 minus 2. So here we have in the numerator 5, and in the denominator it's 0. That's because the x coordinates x1 and x2 are equal. When that's the case, we say that it's an undefined slope. And we can think of the slope as having really infinite slope, very large number, as the x1 and x2 coordinates are equal. Here's another example of finding the slope of 2 points. Let's say we have a point 1 and 4. That's located right here. Another one at 4 and 4, but we note that the y coordinates are equal. So we have one at 4 and 4 that's shown right here. Draw a line between them. And here we define x1 and y1 as an ordered pair of 1 and comma 4. Same thing with x2 and y2. It has an ordered pair of 4, 4. Using the definition of slope, change in y over the change in x yields 4 minus 4 over 4 minus 1 yields a numerator of 0, or the result is 0 slope, which physically and visually makes sense as shown here. So when the y coordinates are the same, we see that the slope is equal to 0. Now we're going to take a look at finding slopes using this form, y equals mx plus b. This is known as the slope-intercept form, where m is the slope of the line defined by this equation, and we want to find the slope. So in order to do that, we solve the equation for y, which is already shown here, and the coefficient in front of x is known as the slope, m, what we calculated earlier. So let's look at finding a slope m from the equations. Here we have it in standard form, 2x plus 3y equals 6. But in order to put it in the slope-intercept form, we have to solve for y. So here we subtract 2x from both sides of this equation. So 2x minus 2x cancels each other out on the left side, leaving 3y. And what we have on the right is just 6 minus 2x. Dividing 3 on both sides of this equation yields the following. 3 divided by 3 cancels out, and we have 6 divided by 3 is 2, and negative 2 divided by 3 is negative 2/3 x. Putting it in the slope-intercept form shown here, we have a slope of negative 2/3 and a y-intercept b of 2. Alright, so here this b is known as the y-intercept because when you substitute x equals 0, then it intercepts the y-axis at b, and in this case it's 2. Let's look at another example. 3x minus 2 is equal to 4. So we subtract 3x in order to solve for y on both sides. So we subtract 3x again from both sides of this equation. 3x cancels on the left side. That leaves negative 2y equals 4 minus 3x. Here we divide by negative 2. So the negative 2 cancels out, isolating y. So 4 minus 3x divided by negative 2. And then 4 divided by negative 2 is negative 2. Negative 3 divided by negative 2 yields a positive 3/2 x. Putting in the slope-intercept form, we have the following. So in this case we have a slope of 3/2 and a y-intercept of -2 shown here when you compare it to this slope-intercept form. So let us see what is meant by parallel lines. Parallel lines is when two lines have the same slope but different y-intercepts. So here's an example. We have one here of a slope, and in this case it's a negative slope that intercepts the y-axis at 2, and we have another one intercepting the y-axis at -1. But these lines are parallel as shown here. For this equation, x plus 3y equals 6, and then y plus 3y equal to -3. When we solve for y, we see that the slope is equal to -1/3. Now let's look at the definition of perpendicular lines. Two lines are said to be perpendicular when the slopes have a product of -1. So here's an example. We have one line here and another line here. So if one is positive, then the other one perpendicular to it must be negative. Therefore, that's why we see the product is -1. So here 2x plus y equals 2, and x minus 2y equals -4. The one here, 2x plus y equal 2, has a slope of -2. Therefore, the one associated with x minus 2y equal -4 has a slope of 1/2. And when we multiply this, 1/2 times -2, that yields -1. Now let's look at how we got these slopes. As an example, x minus 2y equals -4. We subtract x from both sides of this equation since our goal is to isolate y. So we can see it at slope-intercept form. Here the x's cancel, and we have -2y equals -4x -4 minus x. We divide by -2 on both sides, and we have the 2's cancel out on the left side, and on the right side we have -4 minus x divided by -2. And that yields y equals 1/2 x plus 2. Or in other words, we have in this form, the slope-intercept form, 1/2 as a slope and a y-intercept of 2.